right, first. I saw a little bit of this on some of the homework. That's a no. Don't write that. Because the things that can go into a function are either the input values or a set. We have a definition for what it means to plug in a set, but putting X element of A doesn't make sense. So on some of your revisions, if you wrote that, I asked you why this is incorrect. So it's incorrect because X element of A is not an input of a function. That doesn't make sense. I understood though what you're trying to say. I think what you're trying to say is, you know what this means. Oops. You know that f of A means the set of y values. It's the set of y values such that y equals f of x, where x belongs to A. That's the definition. And you were trying to work with that definition. And you've wanted to manipulate something, but you couldn't because you had this awful set definition. And so this is one of those cases where I look at your homework and think, I wasn't clear. So it was a good feedback for me. What I saw from there is really, if I have y as an element of this set, this is a set, means y is a y value. That's what it means. If it's a y value, that means it was a output after plugging in an x. And where did that x have to come from? Where? The set A. And that you can work with. That's something you can work with. Now you can manipulate that and move it around because you know that y has to look like this. I saw something else, a couple other things that I made notations on. Look in your notebook and see if you said, I've got some comment from me, like we don't write this. It's beneficial for you just to admit it because you probably have a revision on it. Oh, yes, okay. You had something like, I saw this. F of complement of X. Because you can't take the complement of a value. No, that's an input value. You can only take complements of sets. So that's the issue with writing that. It's digging a little deeper into the psychology. If you wrote that, I thought, again, that you're trying to find a way to manipulate that function value, knowing that the X belongs somewhere, but it was all packed in the set and you didn't know how to like move it around. So that's why I think that was written. So we can only do this. Can't do it for a value. Likewise, if the complement was on the outside, I think some of you had written complement f of x. That doesn't make sense either.
X is subset of complement f of z, whereas e is.
Yeah, I think I wrote something on yours. Like it was. I think that came from the same place. Like maybe the way I had done my proofs is I wrote it in set notation and I blasted forward without putting like, in this other piece right here. That this is actually the nugget. This is actually the nugget. If y is belongs to here, then y must look like this, and then you can go forward and work with it. And so maybe that's what I was missing when I presented my proofs in here. I'm sure of it. I mean, there's too many of you that had similar kind of notation stuff, so. There was one more thing that kind of struck me. Oh, yes. Some of you wrote f of A intersect B, or f of A union B, that it doesn't matter, is equal to means y, something along these lines, equals f of x, where, oh, no, this is not exactly what you wrote. You wrote something like this. I'm trying to remember what you wrote. Yeah, I remember. Something like this. That's not true. All you know is if y belongs to the complement of this set, then y does not belong to this. That's the definition. And I kind of made marks along your pages like saying, hey, this and this are not the same. They might be, but you have to prove it. So make sure that you put a big cross out on your paper if you wrote that. Not the same. That's not true. What is true is if you have y belongs to the complement of A intersect B, means y does not belong to F A intersect B. I'm just like literally substituting right into the definition. That's all you know. So on your homework, if you didn't find an example, so what you should have like when you kick the tires on this, what you should have found is F had to be 1-to-1. That seemed to be obvious, like as you start playing with examples, like you choose some non-1-to-1 examples. But if you take something that's is 1-to-1, but not onto, you can also generate a counterexample. How many of you found a counterexample that looks like that? Something that is 1-to-1, but not onto, and didn't satisfy the, okay, raise your hand high. Look around. If you got a revision, raise your hand high. Who found a counterexample if you had and something that was 1-to-1, not onto, and it didn't work out? I know more than one person did it. I don't want everybody flooding Garrett. The reason I'm asking you to raise your hand is if you didn't find it, I have a revision to find it. So that you want to find the people who actually had an example like that if you're stuck. Is 1-to-1, but not onto. Bridget, you didn't have one like that? So how did you come up with onto as a criteria for your? I think you put that on your revisions. You need to find an example. So if you don't have an example like that, create an example where something is 1-to-1, but not onto, and it blows it. I know more than one person got this because I remember seeing it. You got it one too?
Yeah.
So that means that onto has to be also a criteria. Carly, question? I feel like you did too. Yeah, I think you did too. Carly worked a ton of examples, like she was trying to get a feel for it. So like Carly, Garrett, they have examples where something is 1-to-1, but not onto, and still blew the statement. So that means that there's two criteria. One is that it has to be 1-to-1, and one that is that it has to be onto, right? So what I kind of walk you through on there's a little worksheet I gave out to go with the assignment. Like if you got, especially if you got all the way for 1-1 and onto, I asked you like to go through this worksheet. So for a lot of you, I asked you to look at F. So let me put all the preamble. Let F be a function going from X to Y, and C is a subset of X. If F is 1-1 and onto, then that's true. That's true. If that's true, then it takes care of number 1 and number 2 in one fell swoop, because you can just substitute for number 1, C equals A union B, and you can substitute for number 2, C equals A intersect B. The intersection and the union almost have nothing to do with it. So those of you who use De Morgan's, I think Cooper asked about it, and I said something about De Morgan's. I was kind of half dead at the time, but I should have actually asked him, hey, where are you at on this? Why are you asking this? But and it resolved number 2, right? You're done. So there's no De Morgan's involved. So how do you prove this part right here? Well, that's what the worksheet does. It walks you through the definitions, going through, and it uses the set definition of function, but I peel it out the way I did on the earlier slide to show you like how to manipulate that as you move forward. And to show 2 sets are equal, what do you have to do? Subsets of each other, right? So there's 2 proofs. So the worksheet walks you through both ways. And if you get stuck, text me. Just snap a picture. I'm here. I'm stuck. Even if it's late at night, text me, because I get up wicked early. You might not even be in bed yet when I get up. So I might be able to answer your question on the other end. Not enough. But I really work at trying to get my rest. So I get into bed at around 8 and I start reading. I stop. I do everything they recommend just to make this work.
And is there like a definition that goes along with that specific group, like definition of?
Yes, this one I gave you earlier, the set definition. Function on a set. But it's more than that. It's a function on a set that you can actually pull. So you need to actually work with that function. Otherwise you can't move it around, which some of you are actually finding, like, I don't know how to actually move this around. That's why we saw these like X and an element of A inside the function set. So you need that one. That's that one right there. So I asked you in the blank, what does it mean for Y to be an element of this? But literally you write out this, and then you'll have something there to work with. Any other questions? Does that help you out with the revisions for this one? Yes.
That's just the, that's just the. Oh, these are like.
Yeah, that's the worksheet. It's written on top of your worksheet, and then you go through. You should be able to get through it. But again, like if something is sticky, just ask me. Like, I don't know what you want in this blank. I have no idea. I feel like we get to watch a lot of new faculty teaching for the first time. And I think the hardest thing, it's not engaging the students, it's not getting to know the students, it's actually figuring out where the students are and having that communication back and forth of like knowing whatever is up here is, there's no gap when what goes down here. I've been teaching for a long time and there's still gaps. So that's why if you took 103 or JEDI, sometimes you get something on the WPR that's like, I have no idea what this is, because there's a communication gap between where you are at and where your instructor thinks you're at. It's really, really hard. I think the hardest thing is actually making assignments and tests so that students actually can meet them. That you've actually taught them so they can meet that. I think you guys actually were in 103 when I was teaching 103. There was something on there, it was like a page-long word problem. And I was gone somewhere and I came back and I saw this page-long just description of a word problem on the first page. And then I think somewhere on the third page, there were all these like, what if the determinant of this thing is 0? What can you say about the matrix? Like, where did these come from? And I came and asked the guy running the class, like, why did you ask these things? It's going to be a bloodbath, an absolute bloodbath. And it was. And what he said is, they need to see problems they've never seen before. Like, no, this is like training people for the ACFT. And on the day of the test, they show up and you give them the IOCT. That's what this is like. It's going to be a complete disaster. And it was. Anybody remember that from 103? That was 4 years ago. Exactly 4 years ago. But it's hard. Like, it's really hard to gauge where the student is at. And you see me struggling. I'm really glad I built all these things in so that you can come back and ask questions and that, it's not the end all. All right, so the next thing I want to do with you guys is get you ready for your homework. I was about to do a